Let's go ahead and take a look at a rational function that looks visually a little bit different than some of the other ones that we've done. Traditionally, we had that 1 over x or a number over x and then plus or minus something off to the side. Here we have it all as one function, so we need to figure out how to work with this and be able to use the ideas that we had before with something that looks a little bit different. So the first thing I might do with this is rewrite this function as I could say negative 3 over x plus 4x over x. Anytime I have a combined rational function or a combined fraction, I can split that up, making both fractions have the same denominator, and then each fraction gets a piece of that numerator. Now, why would I want to do that? If I look at this, I can't divide negative 3 by x and get anything better out of that. But I can take this 4x over x, and these x's are going to divide out. So alternatively, I could write this function as negative 3 over x and then plus 4. And that looks like what we're used to. We're used to seeing that horizontal shift or used to seeing that vertical shift. And now we can actually start to see that. Because if I look at this function, I don't have a horizontal shift, but with this plus 4, I do know that I'm going to go up 4. And as a result, my horizontal asymptote is going to be at y equals 4. But with the x right here, there's no horizontal movement. I'd have to say that my vertical asymptote hasn't moved off of the traditional x equals 0. So I do know my boundaries now, my vertical boundary and my horizontal boundary. Let's go ahead and plot those onto a graph to help us out. So vertical boundary we said was x equals 0. Horizontal boundary is at 4 at y equals 4. So y equals 4 here, x equals 0 there. Now we know where we can't cross vertically and where we can't cross horizontally for this function. Well, how does this compare to the rest of the function? If I look at my negative 3 here, negative numbers with other functions have traditionally reflected this, and this does no different. So if we think back to the original, y equals 1 over x, it had a vertical and a horizontal asymptote and came in these quadrants. If I'm going to reflect that, I would expect it, instead of being up in this upper right, to be in this upper left. Well, let's check it with some coordinates. If I take a table and plug in something on the left and on the right side of my vertical asymptote, I'm going to choose a negative 1 and a positive 1, just for simplicity's sake. I'm going to plug that either into my original function or my simplified function. So I get a negative 3 over negative 1 and then plus 4. Well, that ends up giving me a positive 3 with the fraction. Add 4 to that, I get 7. If I plug in a positive 1, I end up getting negative 3 over positive 1 plus 4. Negative 3 over 1 is positive 1. So if I plot those 2 points on the graph, left 1 and up 7 is going to put me up here on this left side of the vertical asymptote. Right 1 and up 1. Right 1, up 1. It's on the right side, but below the horizontal asymptote. So I know I'm never going to cross the vertical asymptotes, and I'm not going to cross this horizontal as I approach the infinities, as I go further out to the right and further out to the left. So the only thing I really can do is approach them. So on this right side, as I approach that asymptote, I'm going to go nearly vertical and get closer and closer to it. And on the left side of this coordinate, I'm going to go out and then approach the horizontal asymptote. But on the flip side, I can't cross the vertical asymptote, so I'm going to have to drop down right next to it. And then I'm not going to cross the horizontal, so I'm just going to come up and approach it. So I still have that same general shape that we did with the y equals 1 over x, but it's been shifted up 4 because of this plus 4 out back for that horizontal asymptote. And it's been reflected across that asymptote because of the negative coefficient or the negative numerator of that fraction. This then would be an accurate description of either this negative 3 plus 4x all divided by x, or the modified version of negative 3 over x with a plus 4 out back.